Advancements in EHR technologies and increased rate of EHR adoption has led to massive amounts of patient data being available for operational and research purposes. In addition to the EHR data representing patient records, there is an increasing stream of data from mobile devices, wearables, and other biosensors in the form of wellness and lifestyle information. Other sources include financial and billing information, health data from in-home settings, and disease registries. All of this information related to the health status of sick and healthy persons and or the delivery of health care is often cumulatively referred to as real-world data. One of the biggest beneficiaries of real-world data is the research community. With the right gamut of supporting tools and technologies, researchers not only can conduct clinical trials and studies faster, cheaper, and with better quality than ever before, but they can also develop treatments for complex and rare diseases that researchers were unable to deal with in the past. Real-world evidence is the clinical evidence derived from the analysis of real-world data. Real-world evidence is a new form of conducting clinical trials and studies that relies heavily on patient data. One of the key challenges in conducting clinical research or randomized clinical trials is finding cohorts of eligible patients for trials and studies. Up until recently, research organizations would contract with intermediaries, research facilitators, who would in turn work with health institutions to find and recruit patients for research. This process was typically slow and expensive and subjective. In the new realm, researchers can simply interrogate real-world data, i.e. perform eligibility queries, to find patients using various inclusion and exclusion criteria. Researchers can tweak inclusion-exclusion criteria using different biomarkers, for example, to test various hypotheses and identify the right population of eligible patients. However, the fragmented healthcare system in the U.S. and the heterogeneous nature of sources of the available patient data lead to a great variability in the formats and representation the data is expressed in. Additionally, depending on the original purpose and usage for the data, it may rely on different coded terminologies and vocabularies, or not use them at all. These challenges greatly complicate usage of real-world data on a large scale. Not only do they limit the value of the available data, but they also make it difficult to find the right software that works with real-world data. To address these challenges, research organizations chose to standardize on the representation of real-world data in the universe of tools that operate on it. There are a handful of such standards, often referred to as common data models, that are popular in the research communities. The arsenal of tools available to researchers to conduct eligibility queries, especially across multiple heterogeneous data sets, is fairly limited. Finding an eligible cohort of patients is a multi-stage process involving testing multiple eligibility hypotheses, requesting and getting access to different scope of patient data, dealing with consent, and a number of other steps. These steps often take a significant amount of execution time and require scheduled and deployed execution. InterSystems Iris for Health is a perfect platform to support research initiatives. On one hand, it's a powerful and scalable database capable of storing terabytes of patient data and executing complex queries in record time. On the other hand, it's a workflow engine that can orchestrate complex external patient data ingestion processes, as well as distributed and scheduled execution of queries, generating notifications and reporting. Iris for Health also includes an FHIR framework that not only stores data in a standard format, but also represents and exports it as FHIR resources. First Line Software has decades of experience working with major academic medical centers and supporting clinical research, from building research applications to extracting and transforming patient data from proprietary EHRs and other systems to just about any standard data format used in the research communities. First Line Software has mapped a wide range of coded medical terminologies and vocabularies in the United States and around the world. It employs trained business analysts and medical informaticians to support multiple ongoing research efforts. It's only natural that InterSystems has joined forces with First Line Software to bring Iris for Health into the forefront of clinical research. This joint effort combines the power of Iris for Health and other InterSystems technologies with the long-standing expertise of First Line Software engineers supporting clinical research initiatives. InterSystems and First Line Software are collaborating to bring Iris for Health to the I2B2 community and implement support of the I2B2 Query Builder and other softwares on the Iris platform. In another instance, First Line Software is engaged with Bay State Medical Center and InterSystems to extract data from Health Insight to the OMOP CDM on Iris for Health and Postgres. The goal of this effort is to not only implement a data pipeline that transforms Health Insight patient data to OMOP CDM, but also verifies that popular tools used by the OMOP community function correctly against data stored in the OMOP format in Iris. These are just the initial steps to bring the capabilities and power of the InterSystems technologies to the research community. Both teams at InterSystems and First Line Software are discussing and considering further joint engagements that would make the vast power of Iris and HealthShare available to clinical researchers and Big Pharma. Both InterSystems and First Line Software are very excited to be making our humble contribution to the advancement of clinical research and drug discovery.